In this video, we will learn about exponential function and how to use the laws of exponents to simplify exponential expressions. In this general form of exponential expression, a is the base, which is raised to the exponent x. Here are the laws of exponents. First, a to the x times a to the y is equal to a to the x plus y. In other words, if we are multiplying two exponential expressions and they have the same base a, we copy the base a and we add the exponents. Second, if we have an exponential expression raised to another exponent, we simplify this expression by multiplying the exponent. X times y is xy. Next, a to the x divided by a to the y is equal to a to the x minus y. So if we are dividing two exponential expressions and they have the same base a, we copy the base a and we subtract the exponent. So x minus y is x minus y. A to the 0 is equal to 1. That is, as long as a is not equal to 0, since 0 to the 0 is undefined. This means that any non-zero number or expression raised to 0 is equal to 1. Next, a to the negative x is equal to 1 over a to the x. So if a given exponential expression has a negative exponent, its reciprocal has a positive exponent. If the given exponential expression has a positive exponent, the reciprocal has a negative exponent. That is the opposite sign. Lastly, if we have an expression raised to another exponent, we have to distribute the exponent, the given exponent, to each of the variables. In other words, we have to multiply the exponent of each variable by the given exponent. So x times z, xz, times b, then the exponent y times z, that's yz. Let's try to simplify some exponential expressions using the laws of exponents. First, let's say we have 3x squared times the quantity or the expression 2 times x to the 5. First, let's multiply the numbers. 3 times 2 is 6. Now, x squared and x to the 5 have the same base, that is x, so we write x. And then we have to add the exponents 2 and 5. So 2 plus 5, that is 7. Now, this time, let's raise the expression 2 times y to the 20 to the exponent 5. So, we have to distribute this exponent 5 to each number or variable inside in the expression. So, we have 2. Of course, 2 is 2 to the 1. We multiply the exponent 1 by the given exponent 5. So, times 5. Then, we have y to the 20. We will have to multiply 20 by the exponent 5. So 20 times 5. Okay, if we simplify this expression, we get 2 to the 1 times 5 is 5. And y to the 20 times 5, that is 100. Now, if we expand 2 to the 5, that is, of course, 32. And then times 100. Now, let's simplify this expression. 25 p to the 13 times q to the 21 divided by 5 p to the 6 q to the 11. First, let's simplify the numbers. So, 25 divided by 5 is 5. Then we have p. Oh, we can simplify the variables also because we have p. Let's say, for example, the p in the numerator and we also have p in the denominator. So, since these two have the common base or the same base p, we write p. Then, since we are dividing expressions, we have to subtract the exponent. So 13 minus 6. There. Okay? How about the q variable? So since these two have the same base q, we write q. Then again division. So we have to subtract the exponents. 21 minus 11. Now let's simplify this expression. Let's copy 5. 13 minus 6 is 7, so p to the 7. 21 minus 11 is 10, so q to the 10. This time, 1000x cubed is equal to 0. Now according to one of the laws of exponents, any non-zero number or expression raised to the exponent 0 is equal to 1. Therefore, assuming that x here is not equal to 0, this entire expression is equal to 1. Next, we have m to the 4 times n to the negative 3. To simplify an exponential expression, all exponents must be positive. So we have to make this exponent positive. So let's copy m to the 4. And we know from one of the laws of exponents that if we want to make the exponent of a variable positive, we can get its reciprocal. So we multiply m to the 4 by 1 over n cubed. That is the reciprocal, but this time with a positive exponent. To simplify, let's multiply these two. So we have m to the 4 over n cubed. Lastly, we have the expression a to the 6, b to the 9 over c cubed raised to the exponent 4. Now, first question is, can we simplify the expression inside the parentheses? No, because they have different variables a, b, and c. So, we can proceed to distributing the given exponent to each of the variables. In other words, we have to multiply the exponent of each variable by 4. So we have a to the 6 times 4, b to the 9 times 4, and c to the 3 times 4. 6 times 4 is 24, 9 times 4 is 36, and 3 times 4 is equal to 12. If you have any question, please leave a comment.